So when an impulse arrives and it has significant intensity, it can cause what you call depolarization. This depolarization is when you have sodium channels opening and then sodium entering into the neuron, and this basically reverses the 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 charge that we have the inside the neuron. So inside the neuron becomes positive, whereas outside becomes, so it reverses what was initially negative to positive, and then the outside, which was initially positive, becomes negative, and that is what we term as depolarization, and this is what actually causes the impulse to be transmitted. So coming back to our diagram here, when the stimulus is of sufficient intensity, that means it exceeds the threshold value or potential or level. You can use all those words. So at this point, when this is the threshold and it has been exceeded, then you have depolarization happening. This is when you have an action potential, which we know that is an impulse. Okay, so an impulse will definitely be fired there. Now, the impulse will not be fired continuously. You have a moment when that depolarization state is returning back to the polarized state. Remember, at resting membrane potential, what we have is a polarized state. So you have the negative inside and then the positive outside. Now with depolarization, it is the reverse. You have inside being positive, outside being negative. And now, after the impulse has been fired, the neuron has to go back to the polarized state. And that is what we term as repolarization here. That is repolarization. So repolarization is happening because the potassium ions are opening, yet the sodium ions are actually closing. And that means that you will have more potassium ions rushing out. And this brings back the negative charge that is inside compared to what is out. Okay, so that is repolarization. When the neuron returns back to the polarized state, it will not go to its level of polarization as it had before. So what happens is that it goes a little more down, and that is what we call hyperpolarization. And that's why this here, the resting membrane potential, is not exactly what we see here, because there is a dip that we are having there before it coming to the same line as this one. Okay, so repolarization, the polarized state is being restored after the impulse has been fired, and this is basically to make sure that the neuron is again ready for another impulse if it arises, and that means that there is always that resting moment before it can be excited again, and then an action potential can be fired, and that is what relates to what we call the refractory period according to that diagram there. Okay, that's the time of recovery basically, and we shall see the different types there. Okay, so restoration, which is basically coming back to the polarized state again. It will have the sodium potassium pump mechanism with the ATPase enzyme playing an important role there. And propagation of an impulse is that transmission. That transmission is what we call propagation. And the impulse is transmitted along the axon. Now, if you have mailing chain, it means the propagation is going to be saltatory propagation or saltatory conduction, where the action potentials are basically jumping the mailing sheet, which is the fatty substance that is actually insulating the axons. And then there are gaps in between them, and those gaps are the ones that we call the nodes of ganglia. So the impulse goes on jumping. So that's what we call the saltatory conduction. Okay, we shall look at the factors that actually influence the rate of transmission of an impulse, and you shall see that myelinated nerves transmit impulses faster compared to those that are not myelinated, non-myelinated neurons or nerves. And then, of course, we shall look at the diameter of